Hello and welcome to the next lecture for object-oriented programming classes. So let's start from an extra task that I have given you for the previous lecture. So the task was to create a code in C that after compilation Visual Studio default settings for C++, uh, console application will print Fibonacci numbers like this. But there was a constraint that allows to use of letters from define only one time in code except the word define. And there was a couple samples that I've mentioned. Actually, this stuff with define, so again, I have received a couple letters with the correct solutions, so don't worry if I haven't answered you, because all these letters will be on my mailbox, so I will be able to check them at the day of exam to allow to set classes. Don't worry. So secondary. Now I will give you the correct solution for this. As always, I will give you only a brief description of solution, not the full one, because the next solution will be too complicated. Maybe I will show you the full one from one of correct answers of your colleagues. Anyway, so far, uh, the key to solution. So what was the problem with this constraint of letters defined? Actually, letters E, I, N is definitely one of the most popular letters in the keywords, so like int, main, and so on. Return also has these kind of letters. So we need, according to the task, to avoid them. To do that, let's look at this example, like Fibonacci, number is so. Yeah, let's try to make the same code, but with this constraint. Allow to use letters from define only one time. So far, this code is not satisfies this kind of constraint. So we need to do something. We can use word define, and this is a key and a hint for the correct solution. That's why it's okay to use something like define something. Yes. So actually, this kind of task is about to highlight for you the extra syntax, not extra, but default syntax for C code that allows you to do some stuff with the definitions and macros. So the thing is that I can do something like A1 is I or like D, and then I can do A2 E, and then D fine. Yeah. So actually, this kind of uh, encoding so far, I haven't coded the letters D, E, F, I, N in A1, A2, A3, 4, 5, and now I will continue to implement them. So the thing is that uh, definitions and these symbols allows you to, this kind of constructions allows you to work with text. And I want to talk a little bit about preprocessor. The idea is that finally these constructions are not presented in final code that will be passed to compiler. So the idea is that common uh, strategy on building your application is to transform the code in C in after preprocessor, like preprocessor, in uh, preprocessed code, and then it will be passed to compiler, compiler to produce actual the binary or object code, object code. it's it will be a binary code. So as you know, the this kind of code, like text one, is not understandable by machine. So your CPU doesn't support this and doesn't know what to do with that. Actual applications consist of instructions that are encoded in the correct syntax. Let me open, I don't know, maybe HSD, file open, recent files, and just kernel Z. So yeah, this stuff also, by the way, the NTS kernel Z is not something that CPU can understand. It has portions of stuff that CPU can understand because CPU itself, that finally executes a code, don't know what is MZ. It knows it is known format for operating system, for another abstraction that actually CPU doesn't know. So CPU allows to execute instructions that it knows, that is part of something that called uh, ISA, or instruction set architecture. So it's instruction set architecture. So this archi, sorry, my mistype, architecture. ISA is something, ISA is something that CPU can support. It's a number of instructions, registers, and different encodings that it can execute, it can do. It works with registers, it works with memory locations, and nothing more. Or maybe some control registers and instructions, nothing more. So it means that it don't know what files is. It don't know anything about processes, files. It don't know anything about text and letters. It just knows instructions and registers. That's why all this stuff like files and processes are abstractions by operating system, and operating system itself allows you to create this kind of abstractions and allows you to create files, to work with them, to create processes and execute them. But CPU itself doesn't know about that, and with the help of operating system, it can do that. So finally, what I want to say that when you use compilers and Visual Studio, which is not a compiler, Visual Studio is development environment, and the compiler that it uses for C compilation is CLXZ. So Visual Studio is not a compiler. So VS is not equal to compiler. It's equal to developer environment. VS equal to DTE, development environment. Dev and which equals to a set of compilers, editors, editor, editors, um, linkers, and other tools and tools that it including graphical user interface. And the compiler itself, it doesn't have a user interface. I mean, it doesn't have a graphical user interface. It has a user interface which is command line and has a bunch of options. You can actually look at them. I'm sorry that this extra theme and extra information simply because it's about, let me create a new one. This kind of task, like this extra task, always touch some things that are about more deeply understanding of compilation process, languages, and so on. That's why I need to. I think it's a good way to explain you extra things that I hope you know, but it's better for me to give you this kind of information. It will be in English. It's also a bonus, but also if I give you some kind of information, I mean I can ask you this for on exam. So and I also will be sure that you know that. So let's do this. and create a simple project of example one. Let me do it this way. I want to create an empty project, and it will be a console application. So again, this kind of GUI, so Visual Studio and all these windows are not compilers. It's just a graphical user interface. No, I want to add some new item. Yeah, something like this. So it will be include stdio.h int main return 0. So something very simple, and let's look in properties. So the idea is that I was mentioned that Visual Studio is development environment, and it's a set of stuff like compilers, editors, linkers, other tools, and plus GUI sometimes. And this is a GUI, and what it does, it creates some set of options and calls build system that will call compilers, editors, linkers, sorry, which call compilers and linkers to perform actual translation of code to binary. Uh, so this to prove this idea, I want to show you this stuff like debug in 32. So let's look at this. This is options that will be passed to compiler, and the compiler itself is clxz. So you can open it, cl.xz command line. So it's a clxz compiler. Let me. Can I change it in English? Yeah. Compiler syntax. So let's look. It's a tool that actually placed somewhere in Windows. We can actually find it. It should be somewhere in C, program files, maybe Visual Studio 2019 community, Visual C, tools, MSVC, stuff, binary, and host x80. Sorry, host is 64, and I want to x86. This is cl.xz. This tool is actually a compiler. It's not a Visual Studio itself. Visual Studio itself is I don't know where it's placed. Dev in .xz. Oh, sorry, it's not a Visual C. It's Visual Studio. Dev in .xz. Let's look. So I want you to distinguish stuff and differentiate the integrated development environment (IDE), so Visual Studio's development environment, and or IDE integrated development environment. It's not the only IDE that we can see. Also in Mac, also let's say you have Xcode, and Visual Studio is in Windows, and there are a bunch of them. Oh, so here we are. It's an open file location. Yeah, here it is. This is Visual Studio. And CLXZ, so again, integrated development environment is the application that has a graphical user interface that allows you to work with some editors, some bunch of GUI that finally set up the build environment that actually calls, which is console-like, which is MS Build in this time, MS Build, which is a build system that takes as an input the stuff like projects, solutions, projects. We can unload it. So it takes some stuff like this as input and parameters, and then it calls a bunch of compilers, linkers in sequential manner, one by one, including and looking at dependencies, options, and all this stuff. So you can change it. Yes. So Visual Studio is just GUI. It calls build system, which is MS Build for Visual Studio. It also can call a make file, so a make system. It's opposite or like alternative stuff like MS Build to do the same thing. It automates the process of compilation of building applications. And finally, it calls compiler. Compiler does two things. It does a preprocessor, stuff like this, with starting with this symbol, like include, define, and pragma stuff, and does a preprocessor and generate preprocessed code based on this one. Let me show you how it works. So I have stuff like this. I can do a preprocessor. So let's look at the here, and it's C preprocessor, preprocessed to a file, yes, and I want to general and output stuff. Oh, okay, let's build. So I changed the option. Oh, sorry, I cannot open the file output. Yeah, let's look at here, like documents. Sorry, it's this PC. See where it is. Like users. Sorry, user repos. Oh no, sorry, source repos. I have the example one. Debug. Nothing here. Example debug. Here we are. I edit. Yeah, here is an output result. It's source I, which is a result of preprocess of code like this. Let's look at this. So what it does, preprocessor, it replaces uh, lines with this symbol to something else. For example, include replaces line like this of the by the content of this file, and it will do it recursively. So we can look at this. It has a bunch of stuff. So here are our code that we actually have here, and this line was replaced by this stuff, a bunch of stuff that is in include inside. So if we open the include, it has some stuff here, and it also will be recursively replaced by core CRT and so on. So we can check that it ends with something about RMTMP. Let's look at this over here. So all these 10,000 lines are inside stdio, and let's check that we have RMTMP over here somewhere. RMTMP temp name. Oh, RMTMP over here. Yeah, it's that. So you see, it has a lot of stuff that preprocessor does. So really, in real code, you need to, without preprocessor, write this kind of code. All these 10,000 lines. Of course, it has some stuff that doesn't require it, but it has a bunch of stuff that allows you to work with. And compiler itself, it just translates the C code in an object or in a text, in a binary way that CPU can understand. And this kind of code so far will be generated by a preprocessor, and again, let's look here. This is our code. It was taken by preprocessor, translated to this one, and this kind of code will be passed to compiler and returning back to our task. Yeah, preprocess code to compiler, compiler to object file. Object files will be linked together uh, with each other to finally binary code that will be like this. So object file will look next time, not this way, maybe even in autumn. Oh, sorry, not in autumn, but in spring. But still, I want to mention that whether binary code doesn't matter, even if it is object file or binary, like PE, like with MZ in the beginning. It's a signature for portable executable format, and this stuff is generated by compiler. It's a file. So again, we need an operating system that will take this file, understand what to do with that, somehow translate it to process and start it. It's a very simplified way of how the thing's working because like portable executable is not only for processes. Uh, it may take some uh, DLLs, which will be loaded in multiple processes. They are mapped or presented in physical memory one time, but maybe presented in multiple processes. So it is much more complicated, not much more, but it's complicated than I try to explain. But the common idea uh, is that we are working with a C code. C code will be passed through preprocessor, which is a part of CLXZ, for which is part of compiler. In Linux, it's not CLXZ, it's GCC, let's say. Also, it's not the only compilers we have. We have an Intel compiler, Watcom compiler, and so on. So it's like a bunch of them. Um, and preprocessed code will be compiled, so translated from the text way, from the way like this, to something that CPU can understand, and finally it will be wrapped with some headers and required stuff for operating system. And operating system will allow, finally you will get a binary code like this, sorry, the exe file like this. This exe file will be understandable not by CPU but operating system, but still it will uh, have stuff like this, which is a binary code, which was generated by compiler and linker together and produces some functions. So you can see CCC over here. It's a code that is aligned between two functions. So this, I have selected the function inside a hex, which was a result of generation some C code to this stuff. For example, return construction will generate um, an instruction C3 with the code C3, which is a return ret instruction that CPU can understand. Again, this stuff exactly CPU can understand and can execute, but this stuff it cannot. So compiler is stuff that translates this text to this code, and it knows how to do that. So returning back to our task, uh, the task is about to use a preprocessor. So far, I use the define to replace this A1 to D, A2 to E, and so does for all letters. But now I want to somehow bake a simple main by these constructions. So now I cannot use D, E, F, I, N elsewhere except define. So I can use the define and say add D. Let's say it's A, and it will be A, A1. E, A2. I am showing one of possible solutions, not all of them. Of course, you may show some other solution. I just pass it to my test system, and if it not fails, it will work, and you'll get your pluses. So these symbols together means that defines typically replaces a once by d. It does a simple text replacement. But if you use these symbols, it also use concatenation between this stuff and this stuff. So now I can replace main. Oh, sorry, I can use a 1, 2, 3, 4, 5 because D is inside define, so now it's fine. I like do M, or like how I can now make main. Main A is okay. Now I can add I is A4, so it will be like this. And also want to add N. N is A5, so it will be A5, A5. So now it's main. Let's check this and inside a compiler that it works. Fibonacci number, blah blah blah. Okay, build. Okay. Yes. Ma4. Okay. A4. 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 So I can do May. So now it should be May. Ma A4 A and why it doesn't working? Let's say build. Can't use. Okay. Okay. A4. Why it's not working? A4. Sorry, I haven't changed it over here. Haha, my mistake. Okay. Yes. A4. Why it's A4? We can actually do like this. D E I N D E F F I N N. It's also workable. Recursion A5. Sorry. Let's try this. Okay. Yes. Yeah. You see, now I got main, but like this, no A, E, no D, E, F, I, N letters over here. The same for int. We can do A4. Sorry. We can even do like this. A and B. And do B. And now I can do EN, so it will be and N, yes, A5T. Let's check. Well, so Okay, I can do like this. No. Okay, let's check. Okay, A4. Maybe like this. Build. Let's look. Yeah, it works. So now I just need A1, A2, A3, A4, D, E, F, I, N. Say A, let it be before, no, after, and sorry, after and before. A1, A2, 3, 4, 5. A, A1, 2, 2, 3, 4, 5. And before means like this. A. And now here it should work. Now May A5. No, it doesn't work. Oh, sorry, A5. A5. My bad. Main. Hmm. Mm-hmm. Work. Mm-hmm. Okay, I'll do like this. C, A, B, A, B. We can do like this. C, C. We need to concatenate May and A4 and A5 like this. What? I sorry. Say yes. This A B C. Okay, letter is C2, C3, C3. It's something that special for um, like this. May 4, 4, C. Why it's like this? A3. Ah, sorry, yes, my bad. B, C. Build. A4 and 5. Oh, I can do like this. Come on. Why it's not working? A, B, C, B, C. Ah, I forgot how it works. One and C, three. A, B, C. Come on. A, B, C. So C2. Let's check C2 that it works. Come on. Sorry, my bad. You see that it's okay to make mistakes, and that's why we are going to learn how to work with object-oriented programming. It's okay to see the problems, and thing is that I'm doing right now something live that is not prepared that far. I'm preparing only uh, the themes that I will discuss. That's why I may make a mistake. But the thing is that I still want to show you how to work with this kind of um, uh, these kind of solve these kind of problems. Maybe I need to remove spaces because sometimes it may work this way. Let's look. Yes. No. A5. No. A5. Why it still works bad? Hmm. Yeah. I want to describe how to work with AB. Let's try this one. C, AB. Let's try this. C2, C2 will be, yeah, for some reason, let's try this. So it will be A, B, C2, A, B. Yeah, let's try this. So A5, no, like this. Yeah, for some reason we need some recursion. Yeah, it works. Fine. I need C2. Uh, we may also have something like C3, 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 PC. So again, sorry, I was thinking in parallel. So the idea is that I want to show you all these lectures with reality that I also make mistakes and I want to show how to solve those kinds of mistakes. How does the real process works and how real programming looks like. And it's okay to make mistakes. The thing is that your goal is to try to avoid them, of course, but also the thing is to uh, learn how to find mistakes, how to solve them, and what to do in cases when something looks very wrong, and where to look at, and where the mistake may be. And if you create some system and run it, and you see that it works not that way that you expected, you need to firstly understand that bug is from your mistake. So you make mistakes. It's not a compiler, not some external libraries, not something else. It's your exact mistakes. You have done something wrong. Of course, there are some mistakes in compilers. There are some mistakes in external libraries that you will use, but still, the very core understanding is that if you see some problems, the problem is by your mistake. Now, if you really understand that, it will be easier to find this mistake because you know that it's somewhere in your code. It's not in the code of compiler, it's not in the code of library, it's in your code. You see this, you can, and it means basically very positive stuff. You know that you can find it because it's limited by your code. The whole thing to finding the bugs or to finding the mistakes is to uh, to uh, limit them the area where this mistake may be. And most techniques of controlling complexity is about the uh, limiting the area where a mistake may be. So now I have finally figured out how to do that. Now we can see that I can main. Oh, I forgot main. And A B C A B C A5 A5. Again, it's not working. Ah, yeah, it's C2. That is C3. Yeah, now it should work. Now I got. I have to have main. Awesome. Now I want to have int. Also, it will be C3. I is A4 and is A5 and T. Now I can int main without int. Yeah, I got int still. So you see, this is kind of solution you can use. And now for uh, strings, what I can do with strings. With strings, there are a bunch of stuff. So you can use a printf with %d. Sorry, %d you can use. So actually, the bunch of stuff is by octal. So let's say key. Sorry, key table. Yeah, ASCII table. Yeah, here we are. It's an ASCII table, and I need F uppercase is okay because it's not. It's a lowercase over here. I is not good, so I need to see how it will be in octal. I, blah blah blah. I is 151 in octal. Okay, 151. Let's printf this. Printf p 111 build properties. I want to check to no, and I want to run it. No, where I have mistaken, so I think, oh, sorry, it's const char 10. Okay, let's try this, that I have a Fibonacci correct symbol. Fibonacci, yes, I got correct code. So using slash, you can use octal encoding for all letters. You can just check an ASCII table over here to replace required stuff, sorry, for correct symbols. So this is how you can replace it in a string. So this is your solution. Now you have to write a simple code, replace stuff like this, and it will work. So this is about letters. Again, I want to mention that I have made mistakes while showing this example. It's, I think, okay because I want to show you that in real life you will make mistakes, and I'm trying to show you how to solve them because right now I'm writing a live recording, so nothing problem with that. You will make mistakes, but I want you to learn how to solve them, how to deal with them, because complexity itself in programming, you see, it's some kind of simple task, but still I make mistakes because I just forgetting something, forgetting some syntax so that I need to do it not directly but through two macros because this is how it works. It's just why is it like that? I don't really know. It just works like that because of how does invalidating of symbols happening. So that's all I want to say. Another option is that I want to show you that you see uh, we have a preprocessor, we have a compiler, and Visual Studio is not a compiler, it's IDE, and code is preprocessed firstly, then it goes to compiler that translates to object code, which is compatible with the corresponding ISA that is for correct uh, binary. So, I'm sorry, for correct CPU, the CPU itself may be different ISA, so it may be like here is x86. I have a common Intel CPU, but it may be some ARM. It may be running on the phone that is ARM and has separate ISA, and you need another compiler that processes the same preprocessed code but in other object code. Talking about this stuff a little bit more detailed, I'll give more details about that later. But so far, I want to show you also that even these kind of simple programs are still complicated. You see this, that's why we were talking about complexity. That's why we're talking about this controlling of complexity. We have a lot of tools to do that, and so that's why we are going to talk about object-oriented programming, which is the best set of techniques to deal with that. But again, the main your tools are this stuff. So decomposition, metaphor, composition, categorization, goal thinking, and I need to call this. So even this kind of program, you also need to think that any code you write is uh, working will be worked on some environment. In this case, this environment is operating system. That's why we're talking about format that is not understandable by CPU but understood by operating system, and operating system itself run on CPU, and that's why it knows, or let's say, it creates this abstraction of files, abstraction of processes, that it knows how to deal with binary files and what to do with them, where to place them, where allocate memory, do some relocations, and all this stuff to make this code running on actual CPU at some point of time, depending on scheduler in terms of operating system works. So this complication is real life. So you still will create some code, not for very simple controllers, but for operating systems, for complicated controllers, for different parts of the system, for web browsers, and so on. Always think about area where your code will run. And the better you know the area, the better you know the environment where it works, the APIs, the internals of them, the better you can create the code. It works in two ways, in optimization and in security. You are working on security the main because you're specialists of security and you need to know how system works inside. That's why we are doing these classes, and actually we'll have another classes in fifth year of education, fifth or fourth year of education. Yeah, I think fourth. I will give you lectures about how does CPU works, how does operating system works inside, and why we have these kind of rules. You know that I think that to understand these complications or any other complications, you need to know how does what was the cause of doing like that? Like why C looks like this? Why do we have preprocessor? Simply because sometimes it's painful to create a bunch of same way looking variables, or maybe you know that you want to create some constant value and use it multiple times without magic numbers to actually use a metaphor, but this metaphor will finally translate it to actual constant that will not be changed, and it will be encoded right inside here, right in the binary constant. But this constant may be changed, and you want to change it in multiple places. And one time, change it in one place, and it will be changed in multiple places. That's why we have a preprocessor that allows to do like this. You can like A1 and replace it in multiple times, in multiple places. This is how we use metaphor and preprocessor. You will see in most, in almost in all low-level languages, because it's one of the parts where you can create and reuse the code, and simply because this kind of low-level languages like C is tightly connected to architecture of CPU of ISA, and it may you basically create the code that will be translated to exact constructions. Like this is translated to exact construction of a set of instructions. This also will be translated to a set of instructions, and vice versa for every construction in C. It just looks compiler basically looks in simple way looks like a table that translates some construction, syntax construction of C to some portions of instructions of actual ISA. Uh, that's why preprocessor allows you to simplify this code and use a metaphor to naming some portions of code with extra names. This is how it works. Now let's look at, so again, this is solution for this current task. So let's do the third task. Let's, sorry, so let's file, save, and it will be task 3. So task 3 will be more complicated than previous. I think it's one of the most complicated here. I will give you 2 weeks to solve this task and show you a solution in 2 weeks. In commonly, only 2-3 persons give me the correct solution in a year. So the task is like this. You have to the same create a C code that after compilation blah 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 will print Fibonacci like this. So this part is the same. Also, I will keep an extra task for pluses. Where it is? Here we are. Let's return back. Oh, okay. Okay, now I'll also keep this, but for five pluses for solutions I will give you because it's complicated, or let's say it will be 6 pluses, and two extra pluses if you match we as argument for Fibonacci printing. So the thing is that you have to create this application, the code, I mean, for C that prints, but you can you have constraint on your code. You can't use letters in the code at all. So, I mean, try to avoid letters which mean everything which is letter, not symbol. So you allow only to use symbols like 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. So, okay, let's say it's better to say that not to use. You can't use letters, which means that you can't use any alphabetical letters like A to Z, A till Z. So, no letters at all. So, construction define is now also have to be avoided because it uses letters. You can't use even 0x55 because it uses letter like X. You can't use, of course, int or main. It is impossible. Actually, with the main, we have a problem. So the original task is like this. You can't use letters at all. But unfortunately, I have no idea. Let's say, so it's also bad. So the thing is that your code is in C. It have to be linked, and when any code is linking in a final program, you need to have an entry point. So the code that will be executed first. So your code may have 1,000 functions, but some of functions have to be executed first. So in basic, it have to be main. So main, if you doesn't type main, or I really don't know how to avoid these four letters, exact main, exact these four letters at all. That's why I think that it's better to say you can't use letters like this, except name of function, name of entry point, entry point. So your entry point is main. So you can use main if you somehow give me example how to avoid them with default settings. So it means you can't change. Of course, you know that it can do something like properties and preprocessor and user-defined definitions like minus D, let's say 1, 2. So okay, okay, D12 equals main, and do something like this and replace this by 1, and it will work. So I can do let's say properties yes, okay, build, and it still be main. Oh, sorry, underscore 1. So underscore 1 is good actually. Minus D, undefined, sorry. It's not here, it's have to be passed here. How it works. Again, you see, minus D, without minus D. Oh, main, you see. Yeah. I know that I can pass something in a command line, so it will look like this. Yes, I can do that. But according to the task, I cannot do this because I have a default settings. So the stuff that I have shown you is not allowed. Not allowed. So let's keep task like this. You can't use letters, so try to avoid letters as much as you can. There are some stuff that are easy to do, some stuff too hard to do. That's why let's keep it like this. I will give you some pluses. Please show me any uh, solutions if you still you have avoid some letters, but you don't know how to avoid some others. Still send me an example. I will not give you 6 pluses, maybe less, if I see good thoughts and good solutions. But I will give you 6 pluses if you will avoid all letters except main, except here. So nothing else. So name any other application of main anywhere is not allowed. So only as an entry point, nothing more, just to let to generate the correct symbol name compiler to generate a simple name. So no settings changes, like I have shown you, nothing like this. So try to avoid letters. It's possible to avoid all letters except this one. I'm sure for that. I will show you the example how to do that. It really looks horrible, but it's possible. So go ahead, try to think how to do that, and try to use the full power of C syntax that's possible. So go ahead, work with that. Hope you will solve this. So waiting for your solutions again. I'm waiting for them on my email. So now uh, I want to talk a little bit before. So I see that I have already an hour of lecture. So I think still that it's good that I have showed you stuff about compilers. Now I have only half an hour, so I want to mention two things. So let's add something. So it will be add. Okay. So firstly, I want to talk about uh, three means lecture three. So firstly, I want to talk about metaphor, and secondly, I want to talk about compilation process that I have started to. Just I want to complete it. Let's complete firstly, I think about a compilation process and then return to metaphor. A couple of thoughts about that. So, compilation process. We have started to talk about that over here. I have shown you that we have a preprocessor compiler. So let's do this. No, I think it's better to do like this. So it's C or like uh, source code we have. So we have a source code. Actually, oh, my bad. We don't need this. Come on, how to delete this? Yes. I have a source code. Actually, I have not a one file because very rarely we can see only one file. Most common applications right now contains thousands of source files. So let's say we have a bunch of source files. Each of them will be pre-processed at the compilation process. So it will be like this. It will be like this. It will be like this. Yeah. So after the source code, it starts to be a C pre-processed. So it will be a C pre-processed code. In terms of C, of course, not this schema is common not only for C, for Pascal, for a bunch of others, but not for all of them. Let's take C source, sorry, C source code. C source code and C source code. Okay, so C++ for C++ is the same, so it's pre-processed. After that, after that, it will be translated to object files. Object files. So let's look at them. Properties, preprocessor, remove that. Okay, build. Okay, let's look at object file. It's not a 3D object, it's an object file. So I can open with the. Okay, open. It will be in C, user, source, repos, example, debug, object file. Here we are. It's an object file. It has a bunch of stuff like this, and yes, it's some constants, and it has actual actual code over here. No, sorry, over here. It's a very few bunch of code because I have a very simple function. We can even open it in hex editor. So this stuff is a simple hex editor. This one also is a extended hex editor that knows how to parse it. I don't need this. Template executed successfully. Where is I have inspector? Okay. Object file, script templates, archive out executable z file, and doesn't support it. Yeah, no, something wrong. Okay, doesn't matter. Forget about that. I got object file. So let's return here object file like this. So the thing is that it's just direct translation, which means that why do we have multiple files? Because we don't want to put everything on all the code in one file. Let's imagine that you take let's imagine you take a Visual Studio Code, and all Visual Studio Code itself, all features are presented in one source file, source.cpp. Can you imagine the size of this CPP file? It will be absolutely impossible to read, impossible to understand, and so on. So it's better to split it. So again, using decomposition, again, to decompose this one source file. For a machine, for a compiler, it doesn't matter whether it is one compiler, one source file or multiple. It doesn't matter. So we use decomposition to split it and use Metaphor for naming of those source files. So if I'm doing source.cpp, I'm not using Metaphor because source doesn't give me any information about what source file it is. It's just a source file. I know about that. I see that it has already a CPP extension, so it's already a source file. So source name doesn't give me anything. So it's better to use better names, split files, not in source 1, source 2, source 3, but something about subsystems. So object files. This stage is done by preprocessor. This stage is done by compiler. So object files, it's not a completely workable exe files or executable files, simply because operating system doesn't know how to do them, to execute them. Why? Because these kind of files doesn't have all required stuff, which means that if we split a complicated problem to a bunch of C files, which means that some functions will be in this file, another functions will be in another file, which means that both functions use each other because somehow they connected to one to one entry point. So these functions communicate with these functions and vice versa. So which means that separate object file, this file will contain the translated or like instructions encoded of these functions. This object file will contain instructions encoded by these functions, but we need to connect them. Operating system itself don't know how to connect them between each other. That's why we need linker. Linker will finally take multiple object files and link them to one file, which will be an executable. exe. This executable, like this one, like this one, will have everything, and it will take those functions, and each of them will be possible to call each other, and it will work. This is how it works. That's why in linker stage you have problems like undefined symbol, which means there is some symbol that this function uses, but the linker don't know where this symbol is and how to link it. That's why we have unresolved external symbol or unresolved symbol stuff. Each function, each variable, each stuff like this is named symbols. It's just a common name that means that symbol is something with a name. Something with a name may be a function, something with a name may be a variable, something with a name may be some array or something else. So that's why it's called symbols. And symbol is a base option of metaphor because symbol has a name. And at point of object file, it keeps all names of that you have assigned for them using the code. So if you create a function test, it will object file will keep this function test. Let's check this. Let's take a Visual Studio and here like int test. Sorry, int test or return 1. So, and here I can call not only printf on the test. I can build it, and I can look at the object file and look at test. And I see here a test over here. It's a name symbol. It's you see it's a binary representation of table of symbols, and here we are a test, which is I have defined right now. A bunch of other stuff that it uses, and also the same option is about unresolved external. Let's try abracadabra call, and I can build it, and it sees that so far I got a compiler error. C means compiler. Compiler, abracadabra, and define not found. It's okay, I can define it. I can be void abracadabra here. Here is a declaration of the function. It's not a definition, it's a declaration. There is definition. Declaration means there is something somewhere and it looks like this. So REST code can use it because it knows how to use it. It's an interface of this function. It knows how that it has no arguments and then don't need to pass it so far. This is definition. This is what and like how exactly this symbol looks like. This is a symbol, this is a symbol, and also I can define like int ttt equals 0, which is also a symbol, but it's variable. Here is a symbol function, this is a symbol variable. This is undefined symbol. So let's look at now, no compiler error, but linker error I got. Output, so let's look, I have a unreferenced function. It's a LMK error, unresolved external, which means that it's a linker now, it's at this stage bug. Previously it was at this stage bug that it don't know how to use this symbol abracadabra because we don't know what it was. If I do like this, if I comment this, the my code, the compiler, I got a problem over here at the compiler stage, and it will not know how to compile it because it don't know what is this, whether it is a function pointer, whether it is an argument, whether it is a in a C++, it is also possible to create some object with a overloaded operator. So bunch of stuff. So that's why compiler don't know what it is. That's why it needs a declaration. Declaration is over here. So after that, compiler knows how to use it. It knows that it's function, but it don't know where it is. It's a task of linker to find this function somewhere. And because I don't give a definition, it don't know where to find it. You also see that we have symbols, very complicated stuff. Not test, but test, at, a, h, blah, blah, blah. So it's called decoration. This kind of decoration means that because it's a C++ file, and I want to show you that I can change the name to actual test if I do extern C instruction, build it, and I can update this and see now test. I have to see test here, so it's test. Why is that? test build. Oh, sorry, it's on result external. I can do like this. I can, that's why it hasn't generated an object file like this. Yeah, test. Why that? It have to be somewhere. Yeah, here we are. This is test. If I remove extern C and rebuild it, I'll see test like this. So that's why. So again, it's decoration. Decoration is about the same idea. Is it doesn't show. It can't show the abracadabra a x x z because and if sorry, another example, extern C build, and it doesn't an output and result external abracadabra without any add and something else. So this stuff changed the name of symbol inside the binary. The idea is that this name will be changed at the point that when it puts inside the binary. It presented somewhere here. We can find an abracadabra. Abracadabra. Here we are. We have an abracadabra over here. We can remove this and still got an abracadabra. But now it has add and something. So this decoration. This decoration is a special encoding that C++ compiler does to change the name and encode the type of this symbol inside this special stuff, type of this symbol, arguments, and so on. Why to do that? It's because C++ supports overloading. So you can create two symbols with the same name but different arguments. Let's say you can create two functions with different name, with the same name but different arguments. Int 5. Oh, sorry, int a. So it's okay. That's why two symbols can be the same name. In C, not C++. It's impossible to do like that. That's why I can also see that I can rename this, rename to C, and after compilation, we still got object file. Oh, sorry. Let's generate a new object file. Maybe it have generated final. Let's delete. It doesn't generate the object file. Looks like. Oh, sorry, now it generates. Let's check test. Yeah, I got test, and I got test over here. Here is a printf symbol, test symbol, and main symbol that uses. If I type here and build, we got printf is the same, but test will be changed. Test will be over here. So you see, it changes the place where it is. It's okay because different object format, different object format for C++ and C. It has different sections, and it changes from language to language. It's okay. So the main idea is that C and C++ is different languages. C itself, sorry, uses decoration for symbols to allow overloading. C doesn't use it because it doesn't support overloading. If I type the same stuff, hey, it will fail to compile, not to link, but to compiler. Ah, sorry, CPP. Rename C, and let's try to build. And I have to, yeah, function already has a body, so I have a problem because C doesn't support overloading. So to support that, we need a decoration that C++ supports. Okay, secondary. I want to show that this is the main process. So I have a preprocess. I have a compiler that translated to object file. Sometimes it's better to show that a preprocessed file translated by compiler to assembler, and assembler will be translated to linker to object file. So it may be some intermediate step that translates C code to preprocessed code, and preprocessed to assembler, and assembler to object file, and object file to exe file. Well, let's say it happens at the same time in GCC. GCC translates C code to assembler, assembler to object file. It's optional step. Sometimes it happens, sometimes it's not. It depends on architecture of a compiler. For example, TCC compiler doesn't use assembler. It translates directly to object code. So it may be different. It's not really matters. Assembler is a basic language that is very low level, and each instruction in assembler is the same instruction in object file. So this is text presentation of instructions, and this is binary presentation of instructions. So these two files, not that very complicatedly differentiated. So that's okay. So this is a main compilation process. In other languages like Python, C#, it looks differently. For C, Pascal, C++, it looks like this. So that's it. Now about metaphor. I want to mention two things. Is coding. So firstly, metaphor again is your tool that basically means that you can name something. You can name addresses, areas, types, anything. So it's metaphor. The thing is that firstly, it's context dependent, which means that somebody in some context may understand this way. Somebody in the same stuff in another context may be mentions absolutely another thing. The good description or good illustration for that is in Grady Bush book. Let me show you very nice illustration for that. It's really nice. It's about metaphor. That metaphor maybe is a context dependent. Absolutely about this idea. Yeah, looks like this. The same cat and two different persons see different things. That's why the same terminology may be looked. So this is a name of some variable, and somebody may think about this variable like this, and another person may think about this variable like this, which is not good. And that's why when you create a name using metaphor, think about the context. Think about the name to make it as much understandable as possible. So in the context that you expect to. Of course, if you are creating some specific application and you know that your code will be looked by only persons who deal with that, so know this context, it's good to use it, this name. But if you know that it is not very understandable and some person may understand it other way, it's better to select another name. So next option is vocabulary. So to deal with context dependent, you can use a vocabulary. So it means that you can use a vocabulary to um, see that this terminology means that. That terminology means this. So let me give you an example. There are a couple verbs in English that defines almost the same stuff. If we are talking about the type, let's say collection of some object, and it may have uh, methods like add, insert, uh, append, prepend, push. So you see, they're almost the same. They all add some element in collection, but what is the difference between add, insert, append, prepend, and finish, and push? Uh, it's better in these cases, it's better to have a vocabulary that is common for all the projects, and you say that add means only adding element without extra checks. Insert means adding element with extra checks and placing in a specific place. Append means that it's placed somewhere at the end of the collection. Prepend in the beginning, and push maybe add with all checks that possible, but in the beginning, for example. So vocabulary means description about some metaphors, about some terminology, which is very good to use. Again, metaphors are context dependent. So the last thing is uh, code style. So the idea is that it's better to have a common code style over all the project. If you're working on some project, it's better to keep one code style everywhere. Code style means that how exactly, what are the rules and what are the rules and constraints on naming of variables, variables, functions, everything. With the first task, you will receive a code style which is required to use. It's very simple set of rules. Uh, Trust me, it may be much more harder, much more tightly, much more detailed rules. How many spaces between literals possible? When you have to add spaces, when you have not to add spaces, and so on. So a lot of rules, but you will receive a very simple bunch of rules that you have to use. I will check it, and Andrei Yurevich also will check it. So that's why code style, again, code style is the rules how to use metaphor, how to name variables, how to name functions, what are prefixes, what are suffixes, in what cases they have to be like this, in what cases they have to be like that, and so on. Why they are created? Because metaphor is a very powerful tool to deal with complexity, but also with the context-dependent problem, and we have to simplify these names as much as possible. So vocabulary helps us to um, deal with context dependent and say that add means that, insert means that, and so on. And code style allows us to encode in the name of something, like, for example, yeah, abracadabra. What is this? It's an argument. It's a global variable. It's a field somewhere. It's a whether it is a function pointer, whether it is a class with a overloaded brackets operator, whether it is a variable, whether it is a function, whether it is a macro, we don't know. But using code styling conventions or code conventions or code style conventions, code style rules, the same. This kind of rules helps us to name this stuff with a appropriate manner that helps us to understand whether it is an argument. Let's say all arguments have to be an underscore in the beginning. Uh, Let it be the rule. In this case, abracadabra is definitely not an argument. It doesn't have an underscore in the beginning. if or every pointer, let's say we have a pointer, have to start with P, which means that it's a pointer, which is useful. It doesn't have a P, it's not a pointer. It means it's not a function pointer, so it's something like a function or something else. So, set of rules, if everybody follow them, helps us to better understand the code and read it faster and understand what it is. So it's a code styling. Uh, Again, you will receive some code style. So one more thing about code style is that when you are in some, when you are working in some project, you have to follow the code styling rules, which are exactly presented in this project, which are already exist there, because everybody already understands those kind of rules, and you have to follow them. Uh, in this case, you will better understand those code that you already have, and the persons who already work with you also will understand the code you are writing. And no confusion, it will help you to make it simpler. So again, metaphor, code styling, vocabulary, everything like that help you to make your code simpler. The simpler code you got, the less mistakes you will make, and the less bugs you will have, and the less problems with security you will got. So this is the process. Again, deeply understanding of process inside, like compilation process, operating system inside, CPU works, and everything, will help you to also uh, make your code better and make less mistakes. So for today it's all. Thank you. Continue next time.